Hey there guys, today we're going to be doing a generator test. Now this is something that I've done before and everyone seems to really enjoy these videos, so today I'm going to do once again another generator test as it's been a while since I've done one and it's good to give it a test, have it warm up and keep things running smooth and make sure everything's working. But first of all, for those that don't know, I'm going to go over the setup I have. Inside this building here is my inverter generator. So the reason I've done a homemade setup over a store-bought option was for a few reasons. First of all, it's more fun to make videos to show others how I did this and to come up with the solution for all the problems I faced and create something myself. But also, there wasn't a store-bought solution because where I am, there is not natural gas down our street, and diesel is extremely expensive, and we don't have propane. So a gasoline generator was my best bet, and I went with an inverter generator to make sure that I have clean power so that it can run the electronics and the LED lighting will run off it completely fine. So this is the building that the generator is housed in. This has the ventilation, so this automatic damper that opens when the generator is running, and on the other side we have our exhaust fan that turns on when the generator is running to pull all the hot air out, and the exhaust has a dedicated exhaust pipe there. This makes its connection to the garage with this twist lock 30 amp plug. We have a heat lamp which is sufficient unless it gets super cold for keeping this generator building running, keeping it at temperature. Emergency light, we have fire detection, heat and smoke detector. We also have this generator emergency shutdown pull station. If that or these detectors trigger, it will activate this relay, which will emergency shut down the generator. There is our damper and our damper actuator installed over there. We also have low temperature and high temperature alarms. Should any of those trigger, that will show up on our fire alarm system in the garage. This building does have door contact tied into our intrusion alarm system, as well as a siren in here. This is our fan that operates over here to pull all the hot air out. We have various damper controls and power. For anyone interested, every aspect of this generator, I have a full video on basically everything, whether it's the heating, ventilation, the fire alarm, the security, the generator itself, bringing the building out here, all the upgrades I've made, everything's covered on the channel. We do also have indication lights on the generator. This one is just a red light. This is a strobe that was added after. These are nice if I'm, say, doing a test and I'm in the house. I do frequently get people telling me how loud this must be, but it's really not that bad. This inverter generator is already much quieter than the Furman generator I had before. That thing was not very good. It put out dirty power and was loud. And also, once it's in a building like this, this keeps the sound down quite a bit. For now, I am going to close the door because we've already created problems. This is the problem in question. And now it's cleared, probably because we have the door closed. For those of you who have been around for a while, you would know that issue. That heat detector in there gets problematic when it's cold. It doesn't like to be cold. It causes problems. There's probably something wrong with it, but it's so rare it happens, I'm just leaving it for now. But we've talked about the outside part. Now let's talk about the inside part, which is equally as important as the generator. That is our automatic transfer switch. That is this here, and this is what switches power between sources. So between utility power and generator power, if I open up this guy, that's our access. And then we have the transfer switch itself, which you can see we have 1, 2, 3 different timer relays, time delayed relays, because I haven't changed any of the actual, I really haven't changed the basic operation of this. I've just implemented some relays to delay some of those sequences, but in the end it's still the same wiring and same configuration it was from the factory. So it's still not only electrically interlocked, but it also is physically interact with a bar between, which is quite important. But again, I have full videos on all of that, and today I'm going to be setting our generator off by pulling this control fuse. When I pull that, this will basically lose power to all the controls in here, that including this contactor, our utility contactor. So when it loses its coil voltage, the contactor will stop being pulled in, we'll lose power. The generator controller will also lose its utility power, therefore starting the generator, and once the generator is running, that will provide the power for our generator contactor to pull in after our time delay. So let's get started and test this out. Alright, it's been a little bit since we've done one of these tests, so hopefully this goes okay. It's also not particularly warm today, but hopefully it all goes good. I should mention the generator also does have a block heater on it, keeping the engine at a warm temperature so it's not as hard on it to start. I do have two cameras set up. I've got this one outside and the one in the garage, so let's get started. Power out in 3, 2, 1. Alright, there we go. We're on generator power. And just like that, we are now on generator power. Definitely did take a little bit to start up, but you can see our indication lights are on. The fan is now running, and the damper on the other side is now beginning to open. So that's all good. So this generator is now supplying the garage, as well as everything fed off it. So the gazebo, the tower, and this storage shed over here is all getting generator power. We do have a low temperature supervisory. Looks like we also have trouble, so that's probably because that heat detector. Yeah, the heat detector went into invalid reply again. So the reason the heat detector went into invalid reply, well, because it's cold, but also, of course, the reason we got the low temperature is while the temperature's low. Because beforehand, before this was running, everything was cozy in there, not disturbed. But now that the generator is running, it's turned the fan on, opened the damper, so now it's pulling in something like 3,600 cubic feet per minute of this very cold outside air, so that's rushing by everything in there, which is fine. The low temperature alarm is more so for when the generator's not running. You want to keep the building and the generator warm so it starts better, but once it's running, it's not going to hurt it to be cool. If anything, that's just better for the generator to be keeping cool, pulling that cold air in. No problem of overheating, that's for sure. So I am not concerned about that. So that is running all of the lighting, the heat, everything in here just as normal. It powers the entire building. If we took a look at our transfer switch, you can see our utility contactor is let go. Generator contactor is pulled in and energized. We can take a look at the generator controller here. There you have our indication that the generator is running. We can see how long it's running over here. So far it's been running for 4 minutes, total time 12 hours. That's total time with the controller. There is more time on the actual generator itself. But anyways, there we go. The generator does also run all of the outside lighting, like the light pole over here. So I think that's a pretty good test. It's been running for probably 7-8 minutes now, and there will still be a 2-minute shutdown after, so it will run 2 minutes without load on it, just cool it down without working hard. And if the power was to go out again, it would already be running, so it'd be a quick transfer back over. So I'll set up the inside camera and we'll restore power. Okay, I'm going to install the control fuse here. I dropped it instead. Power's going to go back on. Then we'll have a little bit of a delay. Power's on now. That's our neutral delay for a safe switchover without damaging electronics. Sometimes if it's really fast, your frequency won't match up and it can be harmful to motors, definitely, and electronics sometimes won't like that. So that's why we have that delay switching over. Any good generator setup should have a switch over delay. I see a lot of the home standby ones, they make it sound like it's a selling feature that the switchover time is really quick. They act like that's a good thing, but to me it seems bad. Like, to me that seems undesirable, like something you wouldn't want, because of that can be damaging. Any commercial setup should have a neutral delay switchover time, which they usually do. So generator is now in its cool down delay. We can see that looking here. There we go. We are shut back down. There we go. We've melted the snow right around the exhaust. Alrighty guys, well this was the test. That went successful. Started up, switched over, switched back, and shut down, all of which it should. The only issues were, I guess you could say, the fire alarm, but that is not a surprise when it's cooler outside and it's pulling the air in. That's just something that happens, and until I change that detector, that's probably going to be how it is. So anyways, I'd say that went alright. That's going to be it for this test. If you guys did enjoy this video, make sure you give it a thumbs up. If you do have any comments or questions, feel free to leave those down in the comment section. And if you do enjoy the channel, make sure to subscribe. Also, as a bonus, I've got a Instagram account at Pickle700 for bonus stuff. Stuff posted earlier than you'd see it on the YouTube channel, that sort of thing. Alrighty guys, thanks for watching.